If you think about the global carbon cycle on very large scales, we know that as human beings we're emitting a lot of carbon into the air, and we do this through our industries, we do this by driving cars, we do this through cutting down forests to turn them into agricultural fields, and all of these emissions cause carbon to be added to the atmosphere. And we can estimate how much of that carbon is going into the air relatively well because we track how much petroleum is pumped out of the ground, we track trade between countries, and so we know that on average we're emitting about 8 billion tons of carbon into the air. We also have had for several decades now a monitoring network globally where we can actually measure concentrations of carbon dioxide in the air. And based on that global network, we know that on average concentrations in the air go up with an amount that's consistent with about 4 billion tons of carbon per year. And so we have 8 going in and we have 4 staying in the atmosphere, so there's 4 going somewhere else. And the only 2 other places they can go is either into the oceans or into the biosphere. So the biosphere means either plants or soils. A lot of the tools that we're using are really trying to understand exactly where in the oceans and where in the biosphere all this carbon is going. If we continue putting as much carbon into the atmosphere as we are now, in the future, can we expect the oceans and the plants to take up even more carbon? Or do we expect them to stop taking up carbon? Or in a worst case scenario, would we expect them to actually start releasing carbon back out in the atmosphere? There have been studies that have shown very nicely that if you increase carbon dioxide concentrations, you're essentially feeding plants more, and so they grow faster. But it turns out they only grow faster for a certain amount of time, and then they tend to go back to growing more or less at the rates that they would have been growing. As I described before, we have this global monitoring network where we're actually measuring concentrations of carbon dioxide in the air. There's a community of scientists who use those measurements together with information about winds and weather patterns to actually trace back where the carbon that we're measuring at these measurement locations must have come from. In using this monitoring network to solve this inverse problem, to go from the concentrations in the air to the uptakes and the releases in plants and soils, there's different ways to do it. And the way in which my group is doing it is trying to really make as much use of the information content of the data themselves as possible. And so to try to put in as few assumptions as possible and really let the data speak for themselves to help us understand what are the most important processes that are controlling the carbon cycle as we have it today. A lot of what we do day to day is developing really sophisticated statistical and mathematical tools, but their goal is to really help the data speak for themselves. NASA has developed a new satellite called the Orbiting Carbon Observatory, or the OCO. What this satellite is designed to do is to actually measure carbon dioxide concentrations from space. And so it'll be flying around the world, taking very thin strips of data, but more or less everywhere around the world. And I was talking earlier about the monitoring network and how it's very sparse in space and how it's very sparse in time. And the satellite is really designed to solve both of those problems. We are just going to get massive amounts of data relative to what we have available today. My research group has been very fortunate to be involved with the OCO mission for several years now. We will actually be taking the data generated by the Orbiting Carbon Observatory and creating the first global maps from the data provided by that satellite. Generally speaking, we know that carbon emissions affect climate change. What we're trying to understand is why plants and oceans are taking up as much carbon as they are, so that we can predict how this will change in the future. It's only through having this understanding that we can better understand how climate will change in the future and how we can better adapt and manage climate change.